Now we know a solution to a system of equation graphically is represented by the intersection point of the two lines. So let's look at a case that gives us a strange graph. Let's look at x plus y equals 5 and x plus y equals 3. So if I were to graph these, let's subtract x from both sides. This is y equals negative x plus 5. So here I have the y-intercept at 0, 5, and so y-intercept is 5, the slope is negative 1. So I can go down 1 over 1 to find more points on the line. Okay. Next equation, x plus y equals 3. And again, I can put this in slope-intercept form by subtracting x from both sides. Get y equals negative x plus 3. So here my y-intercept is 3. And you could use the slope of negative 1 to go down 1 over 1 to graph a whole bunch of other points on that line. So you should notice these two lines are parallel. And we could have seen that by looking at the equation. And we see here that we have slope negative 1. And in the second equation, slope is also negative 1. These two equations have the same slope, so they're parallel. Which means that they never intersect. So there will never be a coordinate pair, x comma y, that is true for both equations at the same time. So we say that there is no solution here. And we call this type of system, call it an inconsistent. It's inconsistent because it doesn't have a solution.